All right, so here's what we're doing. Got the graph of a rational function. I can tell it's a rational function because mainly it's got this asymptote right here. Okay, that's no man's land. That corresponds to the x value, in this case -4, that causes the function to be undefined. So the function, might be something like this. Well, guess what's going to make the function undefined or make the denominator 0? -4 is going to be the problem number. And so at x equals -4, we get this dotted vertical line that we call a vertical asymptote. Okay, that's what this is called. And oh, good, it got spelled already. Okay, so the asymptote. I know it looks kind of funky. I don't even know where that comes from or its etymology, but that's fine. So we need to use the graph to complete a few things. Okay, so just looking at the graph, first off, we need to determine, the equation for the vertical asymptote. Okay, so what is the equation of that line? Well, like we said, it's x equals -4. Vertical lines always have the equation x equals, and then whatever the x coordinate is for every single point. Notice every point on that line has an x coordinate of -4. Every point on that line is 4 units to the left of the y-axis. So that's what's going on there. Okay. Now, what about the horizontal asymptote? And yeah, we'll see how to find these, like with equations and stuff. But now horizontal asymptotes, well, they're horizontal, so they're always y equals, because every point on the line has the same height, has the same y coordinate, and they're all at height 2. So y equals 2. And that's how you do part A. Okay, so now we got to find the domain and the range of the function. Okay. Okay, so this arrow right here means it's just going to keep going on forever to the left. Okay, forever and ever and ever. And this arrow here means it's just going to keep going on to the right forever. So it uses all x values except for -4. That's why there's a vertical asymptote there. Every other x value is used. Doesn't matter which one you pick. If you pick x equals 4, yep, there's the point. There's a point, or whoops. There's a point right there on the graph corresponding to it. If you pick x equals -2, hey, look, there's the point corresponding to it. If you pick x equals -8, there's the point corresponding to it. But if you pick x equals -4, that doesn't work. So x cannot be -4. That is the domain, or you could write it in interval notation as -infinity to -4. Union -4 to +infinity. All right. Now, what about the range? Well, the range is all the y values that are being used. Well, this right here means it keeps going on up forever, and this means it keeps going down forever. So it's going to go up and down infinitely high. In fact, the only y value not being used is this height 2. So y is everything except 2. Or in other words, -infinity to 2, union 2 to +infinity. And that's how you would, one way to think about doing the domain and range. Okay, now what about the x and y intercepts? Okay, x-intercepts, that's where it hits the x-axis. It hits the x-axis at 4, so x-intercept is 4. How about y-intercept? Well, it hits the y-axis at -2, and we're done. Don't overthink it. Okay, so now it says, hey, let's go graph all vertical and horizontal asymptotes of the function, any that might be there. Okay, so vertical asymptotes occur when the function is undefined, or, oh, poop. I don't even know where I'm at now. Right there. All right, excellent. Where the function is undefined, or where the denominator is equal to 0. So if we add 3 and divide by -3, our vertical asymptote will be the equation x equals -1. All right. So when x is -1, we get a vertical asymptote. All right, cool. What else have we got? How about horizontal asymptote? Okay, now I'm going to show you how to do horizontal asymptote by hand and by calculator. Okay, horizontal asymptote, like we saw in that last problem, is maybe it's right there. Let me do it with the dotted line. Okay, is like right there. And remember, it was something like that, maybe like that. And what that horizontal asymptote does is it tells you what height the graph settles down to out in the end behavior. Okay, it says, all right, let's move away from the middle where all the interesting stuff is happening. And what height, when the dust settles, is what height is the function going to settle down to? Okay. Oh, whoops! I didn't want to get rid of that. Okay, so all right. So here's how it goes. All right. Notice the degree of the denominator is, that's kind of hard to see. Okay, the degree of the denominator is 1 because the highest power of the variable is 1. There's a reason I'm talking about this. And the degree of the numerator is 0 because there are 0 x's in the numerator. Okay. So when the degree of the denominator is bigger than the degree of the numerator, then your horizontal asymptote is just going to be the x-axis, y equals 0, every time. Okay. Hallelujah. Now, what if the degree of the numerator and the degree of the denominator were the same? They both have x to the 1 power, or their highest powers of x are the same. Then, if that were the case, then we would say, oh, well, my horizontal asymptote is just going to be the leading coefficient divided by the leading coefficient. And then that would have been it. And then that would have been like, around there. Okay. What if the degree of the let's change colors, you can see it's better. What if the degree of the numerator was bigger than the degree of the denominator? Then there just is not a horizontal asymptote. There isn't any. Done. Okay. And that happens. Okay, a little bit here and there. Okay, so final vertical and horizontal asymptotes of the rational function. Oh, I didn't do the last one with the calculator. Okay, remind me to do this one. Okay, so the vertical asymptote occurs when the denominator is 0. And so when x is 5. All right. And so we're supposed to graph it. I mean, it's the same idea, except this time you're not given, well, you're given a little bit different function. Okay. Let's see. So x equals 5. 1, 2, 3, 4, 5. Okay. And then what about the horizontal asymptote? Well, the degree of the numerator is 1 and the degree of the denominator is 1. Same degree, therefore, there is a horizontal asymptote, and it will be y equals the leading coefficient on top divided by the leading coefficient on the bottom. Okay, so okay, and then that's where they are. Now they're not asking us to graph the function, but that's okay. So that's what we got. So let's plug this function into the calculator and compare, the asymptotes if nothing else. Okay. So I've got the function into the calculator. Now I'm going to go zoom 6, and it might be kind of hard to tell if we've got them correct or not. But we can at least have an idea of, all right, is there a chance that we've got it right? So we said that the vertical asymptote is x equals 5. Okay, so 1, 2, 3, 4, 5. Oh, hang on. Let me grab this thing. So yeah, 5. So does that look like that could be the vertical asymptote? Sure, yeah. And we've got a horizontal asymptote of y equals -2. So at -2, does it look like that could work? Yeah, you bet. Okay. Now we can double check all that on the on the calculator. Let's verify the horizontal asymptote first. Again, the horizontal asymptote occurs when the function settles down to a certain height out on the wings. So what I'm going to do is I'm going to go to the table and delete these guys. And I'm going to say, all right, what's going on with the function really far off to the sides, like maybe at x equals 1,000 and -1,000. All right. Well, -401 over 199, that's really close to -2, to be honest. Okay. And this guy here is really close to -2. This is kind of the downside of using the fancy fraction. Okay. If I were to go like this, okay, that was the function, right? Yeah. If I were to go like that and not use the fancy fraction, now it'll just give me decimals. Okay. And yeah, the height of the function is settling down really close to -2 when you go really far out. Okay, so I feel very comfortable with our horizontal asymptote of y equals -2. Now, what about that vertical asymptote? Well, that's just where the function's undefined. We say it's undefined at 5. Is it? Yep. Okay, must be a vertical asymptote. No big deal. And that's all we do. Okay, on this one, graph the vertical and horizontal asymptotes of the rational function. All right, blah, blah, blah. All right, so first we got to find them. So vertical asymptote, that occurs when the denominator is 0. So I'll add 2, divide by 2, take the square root, and I get +1 and -1. All right, so at +1 and -1, we've got vertical asymptotes. So yeah, we got more than one. Cool. Very fun. Let's try this color. I'm colorblind, so I don't know if I can't even really tell the difference. Wow. Let's see. You're probably thinking, yeah, because it's the same one. I don't know. All right, so horizontal asymptotes. Well, the degree of the numerator is 1. The degree of the denominator is 2. Therefore, the degree of the denominator is bigger than the numerator, so there is a horizontal asymptote, and it is the y-axis, okay? Or the x-axis, y equals 0. Cool. And that's all they want us to do is just graph those things, okay? And you can, again, go to your calculator, monkey around with the table and the graph to make sure that you got the right answers. That's a good idea.